How's it going, everyone? Welcome to the Exam 2 review video. So quite a few Word documents open here, but this is the one I'm looking for. Questions 1 and 2, these are kind of, as you noticed, I'm sure, in reverse chronological order of how the material was actually covered during the semester. So the first question asks you whether or not true or false the terms artificial intelligence, or AI, and machine learning, ML, are identical, and that is false. If you remember that Venn diagram, and I opened the PowerPoint just so I could show you here, make sure for the exam that you're familiar with this and note that machine learning is a subset of artificial intelligence. So anything machine learning is a form of AI, but there are forms of AI that aren't necessarily machine learning. As I mentioned on the actual review there in the solutions, make sure you can do similar type analysis for the relationship between deep learning, machine learning, and artificial intelligence. So of course, if I were to ask you, is anything deep learning and machine learning, are they the same thing? Well, no, they're definitely not the same thing. Deep learning refers to a particular subset of models that are these large artificial neural networks, and we'll look at that here in a minute. So question 2, data science techniques are typically employed at the end of the machine learning process. That should read false. They're employed in stages 1 and 2, and particularly in the prepare data stage 2 phase. So if you think about artificial intelligence in general, of trying to get machines to act like humans, you're going to need some sort of data that kind of models how humans actually act there. So the use of data, of course, is much more common in machine learning, where particularly you're trying to get machines to learn patterns in data. But if you look at the machine learning process here, steps 1 and 2, these are really the data science steps. Steps 3, 4, 5, and 6 are really kind of more traditional machine learning once you have your data set already developed. So 3, be able to identify the key parameters, number of input and output layers, number of hidden layers, and so on for an artificial neural network. So I am actually probably going to give you this exact question on the test here, but here, where we have here, is the actual diagram that I was referring to. Usually these are drawn in a left to right fashion. The left is the input layer, the right is the output layer. So notice that here the input layer has 1, 2, 3, 4, 5 neurons. The output layer has 1, 2, 3, 4 neurons. So if this were a regression type task, it would be predicting 4 numbers, or equivalently, it could be a classification task where you're classifying between one of 4 classes. You don't have to worry about that detail. Just note this is the input layer, this is the output layer, and these are the 2 hidden layers. So the number of hidden layers is basically the number of layers minus 2, because you're always going to have an input layer, you're always going to have an output layer. Another thing I might ask you is how many neurons are in a particular layer. Here, as I mentioned, just count the circles. In the input layer, there are 1, 2, 3, 4, 5. In both hidden layers, there are 1, 2, 3, 4, 5, 6, 7, and so on. So I know that everyone can count, so I won't do that for you. So 4, write a sentence explaining the similarities and differences in standard deviation and interquartile range, and expect a similar question for mean and median. So if you think about that, when you have a data set, one of the kind of general classes of descriptive statistics that we discussed is the amount of dispersion in the data, how much it actually varies about the actual average or central tendency value. And both standard deviation and interquartile range, or IQR, are measures of that dispersion, how far they're spread out from the average value. However, the way that you calculate interquartile range, remember, it's the 75th percentile value minus the 25th percentile value. So since it's based on percentiles, it's going to be much less sensitive to outliers versus the standard deviation, which, similar to the mean, allows every data point to vote in an equal type fashion. Each data point has equal weight in measuring the dispersion. So if I would ask you that question for mean and median, they're both measures of central tendency, but since median is percentile based, it's much less sensitive to outliers versus mean, where every data point gets the same vote in actually determining the central tendency, even if it is an outlier. In addition, please make sure that you can write a kind of description of what an outlier is. There's a lot of different things you could give there. I'm really looking for your own creativity from an actual data point of view. It's just something that's very, very far spread out from the actual rest of the data. You could say it's heavy right-tailed or heavy left-tailed, but generally speaking, what I'm really looking for is it's a data point that it doesn't resemble the underlying distribution of the rest of the data. So if I were to ask you equivalently as well, maybe this is a better question, what are some sources of outliers in data sets? Well, it could be actual failure of the underlying equipment. Or if it's data that's actually being keyed in, it could be just a typo of someone actually entering a data set. So I'm going to actually stop that video recording right here, and this will be questions 1 through 4, and I'm going to break it up just because I'm going to code in some of the other videos. So I'll see you all in the next video.